Dr. Boghossian.
Hi.
Hi, very nice to meet you.
Hi, nice to
So, Mr. Vachaspati, or Dr.
Yes.
Vachaspati, he's recommended. So I've come to 2 or 3 of these cosmology colloquiums,
Yeah.
and I've asked these 2 questions, and he's recommended that I ask a cosmologist these questions because
Okay.
the physicist prior could not answer them.
Okay.
The first question is, and this is perfect because you do test of gravity.
Yeah.
What experiment have you come up with or have you discovered or seen that evidences the existence of a force called gravity, which as distinct from the effects of density and buoyancy in a medium?
What evidence there is for gravity?
In the experimental. As distinct from the effects of density and buoyancy in a medium.
The fact that planets move around, lots of evidence.
So I meant experimental evidence. So
That's experiment.
what's the independent variable in that experiment?
Okay, I guess you could look at different
Or control.
samples. I mean, you can drop things in a vacuum.
So things are more dense than zero. I mean, so a vacuum there's a zero medium, so everything's
You can
equally
drop
more dense.
Objects.
As
You
distinct-
just take a room,
Yeah.
evacuate the air, and drop
Right.
things, and then they all fall the same.
Equally more dense than nothing, right? They're both equally. So it's distinct from the effects of density and buoyancy.
Yeah.
So gravity is a force that's
Yes.
It has nothing to do with density and buoyancy, right?
Yes.
It exists there whether or not.
Yes,
Right.
it's
So when things fall in a medium,
yes.
it's because they're equally more dense than nothing. In a vacuum, they're equally more dense than nothing. That's why they fall at the same rate. So the question is more as distinct from the effects of density and buoyancy.
Yeah.
If the answer, if no, that's fine too.
I'm not sure I can add more than I said.
Then the second question is, so your cosmology depends upon, so the second law of thermodynamics stipulates that you can't have a gas pressure system in the midst of a vacuum. Like a high pressure always goes to low pressure.
Yes, that's true.
So has it been brought up within the field of cosmology that the heliocentric cosmology depends upon a violation of the second law of thermodynamics?
What is a heliocentric? Is it
The heliocentric model being
centered around the Earth?
heliocentric means, or let's say the cosmological model assumed within the parameters of the general relativity theory, whatever you decide is the center of the universe. But normally you have gas composed stars in the middle of a vacuum. So
So yes, you're right. So if you have gas, it would
Right.
expand into the vacuum. Absolutely.
So do you know of any demonstrations of gas pressure in the middle of a vacuum without a solid barrier between the two?
No.
So would it be true to say that the cosmological model that underpins the assumptions of the popular cosmology, whatever it is, depends upon a violation of the second law of thermodynamics, which is not
because
demonstrable?
there is no. It's not like we're putting. It's first, the universe doesn't have a center,
Well,
it's
yeah,
infinite.
sure. Whether center or not.
and it's uniformly filled with radiation. So it's already equilibrated. So the gas has distributed itself throughout all of the volume of the universe.
Okay, so is that possible to demonstrate, let's say, gas pressure adjacent to a vacuum without a barrier between the two? Is that demonstrable in any way?
I'm not sure.
Let's say I have a
understand the meaning.
pressurized shoebox inside of a vacuum. I poke a hole inside that shoebox. Is there any way to demonstrate air not going into the vacuum and staying inside the box, as opposed to?
I don't think so. As you said, I think you're absolutely right. If you poke a hole, it will go out. I can't think of, unless you just put the shoe inside a very dense, much denser gas or something like
but
that,
would
or put
not
it
be a
inside
vacuum, right?
like water or something. I don't know.
So it's true to say you can't have gas pressure in the midst of a vacuum without a solid container.
Yes,
Okay, so how is it the case that we have atmosphere on Earth without a solid container?
because it's attracted to the Earth.
Via gravity,
By
right?
the gravity.
But why doesn't gravity hold air in the shoebox?
Because the shoe doesn't have enough gravity.
The Earth presumably does.
Earth has a lot of gravity.
The Earth is inside.
And the shoe does.
So why doesn't Earth's gravity hold the air inside the box?
Because, sorry,
Why doesn't Earth's gravity hold the air inside of the shoebox, which is in the midst of a vacuum?
because the gas has pressure. So it has pressure and it just
goes out into the vacuum.
Sorry,
I'm just saying.
I have people waiting and I need to go.
Yeah, all right.
So there you have it. Now you know what happens when you take basic flat Earth and thermodynamic and cosmological questions to top physicists and astrophysicists and cosmologists at various universities, whether they be that of Carnegie Mellon University in the case of Ira A. Rothstein, or in the case of Simon Fraser University, which is the home of Dr. Pagosian, a specialist in cosmological tests for gravity. When asked questions of the kind which should be very simple to answer, pertaining to gravity and gas pressure in a vacuum, professors of this high status either resort to snark, evasion, or are simply flabbergasted and have never been asked by anyone any of these questions. So this should give you resolve and comfort to know that there's not much to it. So I encourage you guys, if the university has ever opened out for you guys, to just go out and visit any open lecture you can and present these exact kinds of questions to your local professor. Alright, if you like that, like, share, and subscribe, and so on and so forth. Bye.
Common trend we can identify if we look at the human history and human attempts to understand the universe. The one trend I could think of is that it never turned out the way we wanted it to be. And I don't mean all the ancient people who thought that the Earth was resting on the backs of the whales, or that it was surrounded by celestial spheres. I'm talking just about the last 100 years. She retarded.